Hi everyone, welcome back. Today we are solving sum of root to leaf binary numbers. So we are given the root of a binary tree where each node will either have a value of 0 or 1, and each root to leaf path represents a binary number starting with the most significant bit. So for example, if the path is this way, then it will be represented as this, and in decimal that would be 13. So for all these in the tree, we want to consider all the path and we want to return the sum of all of these path numbers. So if we look at this example, we have 100, 101, 110, and 111, and these are the four binary numbers, and this is how they are in decimal form, and the total will be 22, so we return 22. And in this example, we just have a node with 0 as the value, so in binary and decimal, that's both 0, so we return 0. So now that we have seen some examples, let's get to how we can solve this problem. So to solve this problem, we can initialize a stack, and each value will be a tuple. The first value will be the node, the second value will be the total value. So we will initialize with the root node with a total of 0, and we will initialize result to 0. Now while the stack is not empty, we will pop from the stack, and we can calculate the new total by taking the total that we have popped right here and shift it by 1, and we will do an OR operation with the value of the pop node. So let's say the root node has a value of 1, we will shift this by 1 and do an OR operation with 1. So now the new total will be 1 because 1 or 0 is 1. Now after getting the total, if the stack has no left nor right, meaning it's a leaf node with no children, then we can add the total value to the result because that means we have made it to the last node. Otherwise, if it has a left or right, then we don't calculate the total yet, but we add the left and right nodes to the stack. And we will continue that until the stack is empty, and then we can return result. So let's go over this example real quick. Now instead of listing the node and the total value, I think for simplicity and better readability, I will just list out the binary representation of that node, and I'm not going to list out the calculation of the total because I think that's pretty self-explanatory, but in case you're wondering, I'll review real quick. So let's say we are right here, the total is 10, right? Now let's say once we are down here, then we will shift this entire number by 1 to the left. The number will now be 100, and now we will do an operation with 1, which we are on. 1 and 100 would be 101, so now this is 101. But anyways, let's go over to this example. So first we are at the top, we need to pop it, and it has a left and right node, so we add them to the stack. Now we can come to the left side first because it's at the end, so we will pop this, and it has a left and right node, so we add them to the stack again, which is 101 and 100. Now we can come to the left side. It does not have a right or left, so we will add this to the result and pop this, which is 4 in binary, so we add 4. Now we come to this one, the right side. This does not have a left or right, so we pop again and add to result, which is 5, so now result is 9. Now we come back to this element, which is right here. It has a left and right, so we add them, but we need to pop first, and now we can add the left and right. So we come to the left side, it doesn't have one, so we add to result, and this is 6 in binary, so it's now 15. And now we look at this side, it does not have a left and right, so we pop and add to result as well, which is 7, so now the result is 22. And now that stack is empty, we can return 22 as our result. So the time complexity would be O of n, where n is the number of nodes in the tree, because that's the number of nodes that we will have to look through to calculate the total sum. And the space complexity would be O of h, where h is the largest height of the tree because that is the largest number of nodes that we will keep in a stack at a time. So now let's get to the coding part. So first we'll initialize result to 0, set stack to the root node and 0 because that is our total. Now we will do while stack, and we will pop. We want to get the node and the total, and we calculate the total by shifting the total to the left by 1 and do an operation with the value of the current node. And now we want to check if node.left is none and node.right is none, meaning it has no children. If that is the case, then we will add total to result. Otherwise, we don't need to add total yet, but we need to append the right node and left node if they have them. So if node.right, stack.append node.right and total. And we will do the same for the left side. If node.left, stack.append the tuple of node.left and total. And after all that, we can return result. Let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.